Hello students, and welcome to another how-to video. Today we're going to be learning about mass-to-mass calculations in stoichiometry. So we've got a problem. We're already familiar with this one. We have ammonia, we have nitrogen and hydrogen, okay? And we're going to calculate the number of grams of ammonia that's made when we have 9.88 grams of N2, and it reacts with an excess of hydrogen. Now, in this problem, hydrogen is not our limiting reactant. Okay, we're going to learn about this in the next chapter. So N2 is going to limit how much we can make. So we want to know how much can we make based on 9.88 grams of N2. Okay, so first thing we got to do is write out a balanced equation. And we're going to do it this way. So we have N2 plus H2 is going to form NH3. Now, our nitrogens are off, so I'm going to add a 2 over here. Now there's 2 nitrogens, and there's 6 hydrogens, and I'm going to add a 3 here, okay? We've balanced this several times now, so you should be familiar with what I just did, okay? The next part, calculate the number of grams of NH3. So we want to know the grams of NH3, okay? We're not looking for moles this time, we're looking for mass. And what is excess? So we have plenty of this, and we only have 9.88 grams of N2. Okay, so how much can I make of NH3 if I have this much stuff? Well, that's what we're going to find out. Now, our mole ratio is going to be based off our nitrogens to ammonias. So if we have 1 N2 per NH3 for 2 NH3s, okay, we have based off our coefficients, or it's going to be either 2 NH3s per 1 N2s, right? So our mole ratio is going to be 2 to 1 or 1 to 2, okay? And we're going to base it off of our calculations down below, which one we're going to use because of the picket fence that you've learned, okay? Now let's work with what we've got. So we have 9.88 grams of N2, okay? Now we can't work with grams. We've got to convert it to moles so we can use our mole ratios, okay? All right, so let's go ahead and switch nitrogen. If I have my periodic table here, we have 14.01, and because it's diatomic, we need to times this by 2. So it's going to be 28.02 grams of N2 per 1 mole of N2. Okay, and now these cancel. And now we're at moles. Now we can use our mole ratio of 1 mole of N2 versus 2 moles of NH3. So if we write it out down here, which one am I going to use? Because I want N2 is at the top, we need to cancel N2, so we're probably going to use this one right here. All right, so I'm going to have 1 mole of N2 per 2 moles of NH3. All right, so I'm going to cross these out. So we used our mole ratio, okay? We're slowly working our way across. We converted our original mass into moles, and then we compared it to our mole ratio. And now we're going to take our mole ratio and we're going to convert it back into grams. So for 1 mole of NH3, okay, let's calculate this. So I've got 14.01 plus 1.008 times 3, right? Because we're trying to calculate the molar mass. It's 17.03. Let's go that far. 17.03 grams. So if I had 1 mole of NH3, it would weigh 17.03 grams. So we're converting this amount into grams. Okay, and then we can find our total. So all we got to do now is just multiply the top and then basically divide by 28.02 because these are both 1s. So if I have 9.88 times 2 times 17.03, which is 336.51, and I divide by 28.02, I get 12.01. So I'm going to say 12.01 grams of NH3. Right, because we're now in grams, and we're specifically talking about NH3, right? Okay, that's how you would find it. Now let's just see if it kind of makes sense. If I have 9.88 grams Okay, it's close to 12.01 grams. Well, nitrogen is going to take up the bulk of the mass, so that does make sense to me if I look at this problem, that we could make 12.01 grams, right? Because for one molecule of nitrogen, I can make 2 molecules of NH3. So they split up, but because they're so heavy, they take up the bulk of the mass of this ammonia compound. So, all right, thanks for watching.